right. Okay, that's right. So yes. Okay. Yes. So, so in last class we had seen about um, how to do the parts for lever safety valve. So we'll continue with that. Yeah. And here, so there are totally there are totally 14 parts, out of which we've seen already a few. That is part number 6 and number 7, 8, 11, and so on, which are the simpler ones. So now we'll see the remaining. Okay. Okay. So yes, we had seen in part number 9. Yes. 4 also we had seen. Part number 10 also was the last, I think, so that we have done the last class. Valve sheet part number 2. Okay, so we'll see this valve sheet. Okay, so now go to valve sheet. Okay, so what is that valve sheet? Let us just take a look at it. Yes, so it's now if you look over here, yes, the overall length is for 120 and from N10, but from the uh, vertical edges that is there, it's about 104, right? And yeah, so here we have 28, and this particular protrusion is for about 6 mm. Okay, and yes, so we have notches for 2 notches, that is of 6 into 12. So we'll see how to do this. Okay. Valve seat. Now we'll go to sketch, select the horizontal plane. Okay, not the horizontal plane, we'll take the vertical plane itself. Yes, we'll draw a line vertically. Then from there, we'll draw it for 104 by 2 because we want to do a revolve protrusion. Okay. Yes. That extra protrusion for 2 mm, and then from there, we'll offset one line by for 64 distance vertical line, and then we'll join it. As per the given dimensions, we'll draw it in a manner such that we can go for revolved protrusion. Okay, that is this. So this also by a distance of 50 mm. So that's how it looks actually. Right? Now we'll go for this, go for revolve protrusion and then this. There's going to be a thread, external thread onto this cylindrical surface. That is for about M114 if I'm correct. That was what was mentioned in the given diagram. Right? So M115 and save this. So lever seat valve, or you can do it as only the part name, valve seat. The material that has been mentioned in the table. Right. So that's part number 2. Let's see the next one. Where part number 3, I think we have done this in the last class. No, where we haven't done. We'll see how to do this where. So if you look at this, so yes, so now if you, they've given a cross-sectional view of this valve, right? And you look at the dimension, there's a diameter symbol. So it has to be cylindrical in shape, okay, or with some circular profile, right? So it has got a diameter of 104 and overall height is 50 plus this one 20. So totally 70. And here there's a protrusion here for about 8 mm width, okay. And the inner regions, the inner V shape or the bottom V shape is for a diameter of 100. Okay, and here where we get the sharp corner tip with which joins the upper and lower V shape is for a distance of 5 mm. And the distance from the above is this the particular top. Uh, uh, I mean the upper V shape, the top edge are the points to the center of the V is for a distance of 50 mm. Okay. Now we draw this seat valve. Just a second. It's the part name. Part name is only valve. Right. Okay. So as given over here, overall length is 70, 50 plus 20 we had. So this distance was for 20 mm. Okay, and here we have, and here we have this 20, and this particular thing we have it for 5 mm distance, right? And the width over here is for 8 mm, right? The overall distance from end to end was 104, so half of that 52. Okay. Now go for this revolve protrusion. Yes, so this is how the part exactly looks like. Okay, so it's a simple part, but we have to read the drawing carefully. Right, number 4 is cover, part number 4. Yes, cover we have done in the last class. Number 5, cover brush. For the cover bush, that is also a simple part. Yes, so here on one side we have 36 mm diameter, inner diameter is 28, and onto the other side diameter is 38. Okay, and this particular, when you look at from measuring the vertical measure, what if you see the vertical measurements, first step is for 6 mm and then further on for another 24 mm. So since there is a diameter and this is shown as a sectional front view, so it has to be a cylindrical part. Okay, then we have done this. I'm not sure. We'll look at it once again. Cover brush, cover bush. Sorry. So we can select the front view plane itself. Actually, over here whether we select front view plane or top view plane depends upon how it has to be assembled. Yeah. So how is the part actually going to lie in the assembly? Diameter, another diameter of 36 for a length of 24 if I'm correct. Yes. Okay, and now at the center it has to be, there should be a hole of diameter 28 at the top surface and go for hole throughout the end-to-end surface. Document number, always let it be the serial number in the part list. Okay. Right. Next, we go for cover bush, then spindle, part number 6. Yes, we have seen this. Toggle 7 also we had seen. Toggle pin, which is part number 8. Yes, we have done this. Lever gauge number 9. This also was done in the last class. Lever guide, yeah, lever number 10. This also we had seen. Fulcrum pin number 11. number 11, yes, this also it seems. Then number 12 is weight. Yes, this weight we have not seen. Yeah. Right, so yes. So if you look at this picture, yes, if you look at this, here they are given one is the side view and one is the sectional front view, right? So sectional front view here we can see and the side view. So in this view, it looks like a circular disc with some dashed line inside. That means there is some hollow space in this particular shape and size, right? Which has got for a height of 22 and a width of 82 mm, which is at the center. And when it comes closer to the circumference, it becomes 66. Okay, out of the that is for the remaining portion. Right. Now, what is the overall diameter of this circle that we have? It has been mentioned over here, which is for a diameter of 356. Okay, and here there is one more cutout or a hollow portion over here, which is for a diameter of 76. Okay, and then the thickness of this hollow portion that is there inside, that is this hollow portion which is mentioned in shown in dashed line, is for a distance of 40 mm, and here over here it is for a thickness of 20 mm, right? Okay, and yeah, the thickness of this weight is 144 mm, right? So we'll see how to draw this. So select the front view plane, diameter of 356, draw that, okay, and protrude it for the given thickness. Okay, we go for coincident plane, this offset plane, parallel plane. Let's show you once again. Plane, parallel plane. We'll draw one more plane for this, parallel to the front view plane. Okay, select the front view plane, keep it at a distance of 144 by 2, that is 72 mm. Now select that offset plane, draw another circle of 346 diameter. Yes. Go for, just show you once again here, the diameters of both these circles are different and it has to be connected to form a solid part, right? So we'll go to this revolved protrusion, click on the down arrow, we get the other options. We'll go for lofted protrusion. Okay, lofted protrusion. So whenever we have the cross sections or the end-to-end surfaces are of different sizes, and we still need to connect it, then we'll go for lofted protrusion. So click on lofted protrusion, select the two circles, and click on preview and finish. Now we'll mirror this. We'll select the solid part, then click on smart, then click on the front view plane. So we get it onto the other side. So we are doing this because here, if you look at it, it is of this particular shape, curvature. Okay, when you take a cross section, it's not just a plain cylinder. If you take a cross section, it appears to be like a rectangle. It's got a curved surface just like a tire. Okay, right? So that is the reason why this has been chosen. Go to the other plane, draw a rectangle for the given dimensions. That is, now we are trying to draw this particular portion, this one. Okay. Draw the rectangle, place it exactly at the center. The width of the rectangle should be 40. Height of this should be 222. Correct. So place it exactly at the center. It's not there, so we have to shift it. And extend it, symmetric extend on both the sides. Select the same plane, go for intrude option, and we'll draw the other one. Okay, that is on the top portion, the narrower region. We'll go for cutout, symmetric extend. For a distance of 66. Okay, and mirror the same thing onto the other side also. Right, so now you can see on both the sides it has been cut out. Right. So now we'll draw a circle onto the flat surface of the part that we have drawn for a diameter of 102. Then offset the plane. By a distance of 62 mm. 62. Yeah. The distance of 48. Yes. Draw a circle of diameter 76, center. And now go to lofted protrusion. Join these two circles, lofted cutout. Okay, so here, one second. Drawing the circle for a diameter of 76. Okay, see the bigger diameter is onto the flat end of the part that we have created. The smaller circle is inside by a distance of 48. Okay, and these two have to be connected so that it forms like a truncated cone, right? Yeah, now for that, and it has to be cut out, right? Material has to be removed. So for that, after this uh, revolve protrusion, then next one we have a cutout, the next icon. Then here we have another one, revolved cutout. Okay, so when you click on the down arrow there, we have something called as lofted cutout. This has to be selected. Lofted cutout. Select that. Select the two circles and go for preview. Click on finish. Yes, so material is removed, and the same thing has to be to the other side also, so we can mirror this feature. So it cut out the given diameter completely. Okay, through from one side to other side. This is the part. Yes, that's how this part is to be done. Let's see the next one. Yes, so let's see, wait, lever pin number 13. 13 also we had seen in the last class. Stud M, yes, stud also we had seen. So the only left out part now is going to be part number one, which is the body of the lever safety valve, which is bit to read this drawing carefully, understand this. So here they are given a sectional front view and a top view. Yeah. Right. Okay. Now when you look at from the front view, it looks like a part not exactly a pot, something similar to that, which has got a flat ends on top and bottom, and on one side we have another flat end which is a protruded portion. Okay, and it is hollow at its center for a thickness of 18 mm. Right, you can see here the dimension that has been mentioned over here. Right, here also 18 mm, here also it is going to be 18 mm, here also 18 mm. So on all the sides, in most of the places it is for 18 mm. Okay, only in few places it is going to change, we'll see that. Okay. And how are these flat ends going to appear? And when you look over here in the top view, they are given it clearly, it is a circular portion, and we have holes of 6 holes that is going to be placed of M20. Okay, where if you look at this, right, yes, so if you look at this, you can see here the angle uh, at which the holes are being placed is given. So we have these 2 holes on exactly at the center on the vertical line. Then these 2 is at an angle of 60 degrees, right? And these 2 holes should be onto this place at a distance of 128. Okay, and you can see this is just nothing but uh, uh, the pitch circle that we call, okay, which is for a diameter of 210. Okay, and this protrusion that is there onto the left side is the flat end is placed from the center of the body at a distance of 188. Okay, now coming to the front view. If you look at the front view, yes, the base is got a diameter of 230. Okay, thickness is 28. Then we have some different shape. If you look at this shape is different that we have onto the left side, and this shape over here onto the right side is different, right? So over here the diameter is going to be 100 for the hollow portion. Then when it comes to the next step, it's going to be 124, and here it is going to be threaded for a diameter of M114, right? And this height is 32, right? Okay, and yes, now going to this curved region where we want it like a pot, from the center, the radius of these arcs are, inner radius is 92, and then after that the thickness is 18. So 92 plus 18, okay, all right. So 110, that will be the radius of this particular arc, and here once again on top we have a different diameter. See, it is the inner diameter is 134, but whereas at the bottom it is different. Okay, and then subsequently above that we have a step for a distance of 10 mm, a step cutout which is for a diameter of 140. And here onto the left side, the diameter of this is going to be 230. Okay, and thickness over here is 25. See, it changes here, it is 18. This is 25. The inner diameter over here is 100. Okay, yes. Now look at the bottom. The base of the base diameter is 230 over here. At the top surface, the diameter of this circle is 260. Right? So many variations are there. So we'll see how to do this part. Okay, yes. So I'll go to sketch. select the front view plane. Okay, we'll include and we'll take the horizontal line. Go for offset for a distance of 168 mm and we'll get it below. And go for line, draw horizontal line for 230 by 2, that is 115. Then for a height of vertical line for a height of 28, then get it in horizontally. Okay, we'll offset the vertical line by a distance of 68. Another line, offset line for 15 mm. Now again offset for a distance of 66 from the horizontal or from the base. One more at 25. Go for fillet over here for radius of 6.5. Arc by center from here where we had the two planes intersecting, from there we'll go for a radius of 68 now. Yeah. Then offset that by a distance of 18 because this is going to be the inner surface and this is going to be the outer surface. And now we know where it is going to intersect, and now we can trim that extra regions by giving a fillet. So we'll go to offset distance by a distance of 83. Sorry, radius 83. Let's now offset the horizontal line, that is the horizontal plane we have chosen, from there 50 mm below, to the unwanted surfaces wherever it intersects. And now we draw only this portion of the part, and this will go for revolved protrusion. So now we have drawn only a portion of the body. Keeping the same thing, draw the remaining, draw an arc, and offset this by a distance of 18. So we need to take the vertical line at the center or the vertical plane, draw a line over there, and draw a line above horizontal line. Offset this vertical line by a distance of 67. Another one at 70. Then another line by 130. Yes, so from top offset it by a distance of 25 below. Trim the unwanted lines so that we have it's going to be hollow in shape when it go for revolve protrusion. Now go for this revolve protrusion. Yes. Now if you go for section, if you have to just have a look at it, you can go for this and draw the rectangle and yes, remove it like this. So we can see how it is going to appear. Yeah, as well as not just for appearance, we can do the changes that is going to be at the center. So we'll go for hole, diameter threaded hole of diameter 115 M115. Okay, and hole depth 32. So we'll draw it from top view, and yes, right. So now it has appeared only for the portion as we have taken only a sectional view. Okay. Next, another hole of diameter 124 for a distance of 32. Okay, so from there, from the existing surface, from there another cutout for 32 mm. Another cutout of 100 diameter. It's completely. Now we can get back this. You can see the hollow portions inside. Now we'll draw the side one. Now offset plane a distance of 188. Yes. Now from that offset plane, we'll draw a circle for the given diameter. So here we have a curved surface for which it has to be connected from the cylindrical portion that we have drawn. Okay. After this protrusion for a distance of 25 mm, now we'll select the inner flat surface. Go for circle diameter 100 plus 18 plus 18, so 136. Draw that from the center. Go for protrusion. Okay, up to here we have the various options. So up to next surface. Okay, right. We don't want to get extended inside also and cover up the hollow portion. Right. So here from the left, starting from the left, out of these 4 icons, choose the second one. Go up to the next surface. Now you can see that exactly it has been protruded according to that surface that is present where it has to be connected. Okay, though it is a curvature portion, will get extended properly. This is going to be a hollow portion over here. So as per the given dimensions, we will make it hollow. So this is a cutout of hollow portion. Yes. So draw that pitch circle that we need, and then use that as the reference to draw the holes in a circumferential manner or in a circular pattern. So here we have circular pattern. Okay, that we can select the hole that we want. Click on OK. Draw the circle along which it has to be fitted, and only then we'll be able to get these options: radius, sweep, number of counts, and so on. So count is 6. Okay, so at the bottom it's equally spaced, but on the top it is not. Okay, and even on the left side, the protruded portion, draw a circle of 180 mm diameter. Now go for hole options. Diameter 20 is the diameter for each hole. Yes, depth is 25 mm, hole depth. Place the circle onto the pitch circle. Finish it. Then go for circular pattern, select the circle, the hole that we have made, accept it, and go for coincident plane, select that plane. So now draw the circle. So we get the radius, sweep, or the angle, number of counts for the circular holes that has to be placed in a circular pattern. It is to be 6. and it's the same manner how we did it for the base. Now we'll go for the top surface. First draw the circle. A diameter of 210 mm. Okay, threaded hole here. M20 for a depth of 25. This has to be on the top surface. Yes, now go for in similar manner. Go for circular pattern, select the hole, then select the plane on how it has to be rotated, the plane on which it is going to lie. Right. Draw the. Look here, we have not selected this particular option, the circle. We have selected only an arc because we want this hole to be placed only for a particular angle for a particular region, not for complete 360 degrees. Okay. So then give the radius and just draw the arc starting point from where we have already made one hole till the required extent. So we want it only till here, that is for 180 degrees. Okay, sweep angle 180, number of counts. In this 180 degrees, how many holes should be present? Okay, we want 4 holes to be there. And click on OK. Right? The remaining 2 holes are not placed at the same distance. Okay, so that is why it has to be separately. That we will see now. Go for hole, threaded hole options. M20, depth is 25. Select this plane, top surface plane. Place these 2 holes, then on the pitch circle. Yes, now from the center, measure this distance. It has to be, the 2 holes should be at a distance of 128. That is what was given in the drawing. So 128 means on one side it is going to be 64. And now get it onto the pitch circle. Yeah. Fix it to the pitch circle. And check it onto the other side also. So now do this. Appears to be all the 6 holes are equally spaced. Actually, no. Actually, it is not. Okay. These 2 holes are placed at a different position. Yeah. So we'll offset the plane, distance of 83. Draw a circle onto this plane for a diameter of 50. And this should be placed at a distance of 68 from its base. 66. And extend it up to next surface. threaded hole. So onto that. Now if you look at it, take a sectional view. Right? This is how it looks. Okay. 1 second. Sorry, there was some discussion about the college matters. Okay, right. Okay, so we'll continue. So this is how it looks when we take a sectional view. So it should appear the same way that they're given in the drawing. So we have to do so many operations step by step over here. Yes, so it has been done. So we'll go to save the part. Right. Okay. So yes, with this we have completed all the parts that has been given for this particular assembly. Okay. Yes. Any doubts, or you want me to repeat it? Anything over here? Any part for this assembly? Yes. Any doubts? Or do you want me to repeat anything?
No, sir.
Okay. Okay. So now, yes, start practicing these drawings. Okay, and I've posted this in the Google Classroom, as well as I'll share this drawing in the WhatsApp group also, so it's easy for you all to refer. Okay, because this is not there. This particular assembly drawing data is not there in the uh, in the uh, in the newer textbook also, or in the older textbook which has the green color of KRG author is also not there. Okay, so right. Okay, but when you say leave a safety valve on, if you search it on internet, you get different sets of drawings with having different data, but this is the one that is there in our syllabus. Okay, right. Okay, right. Okay, so 1 second. Yes, Madhu P. and say attendance. Madhu P is absent, not there. Mane Paniraj never attended. Okay, Maushin Shaukat, he is also not there. Naman Shivananda is also not joined today. Shrikant,
Present, sir.
okay. Then Parthasarthi. Parthasarthi,
Sir is texted in chat box.
All right. Yeah, Parthasarthi, please contact me. Okay, after the class. Yes, Rajat, Rahul Rathod.
Present, sir.
Okay. Yes, Rajat M. Patel.
Present, sir.
Okay. Reni Sibbi is not there. Never come to class at all. Shreyas. Shreyas S. Is also not there.
Sir, 22.
What were you doing, man? 22. Where were you?
Sir, my charge was over, sir. It got switch
Huh?
off, sir. I was joined, sir. Till 9:30 I was joined, sir.
Okay, okay. Yes, Samarth.
Present, sir.
Okay. Sam Govardhan.
Present, sir.
Okay. Sayatan Banerjee.
Present, sir.
Shashank KS.
Present, sir.
Okay. Shashank MV.
Present, sir.
Shivkumar Patel. Not there. Sri Harsha Prasad. He is also not there. Yeah. Shubhankit Singh.
Present, sir.
What Shubhankit Singh? One class you'll come, one more class, the next class you'll not be there. Huh?
Sir, I was present, sir.
Huh?
Like, sir, in my knowledge, sir, I have attended the class.
What?
Sir, I have attended the class. Like last class also, I have attended.
Last class you attended. Previous to that you are not there. Huh? One class you'll come, two classes. Suddenly
I,
you'll not be there.
like
Huh?
my sir, I told you, na, my phone was not working properly.
Huh?
That's I was in lab. I was not.
Anyway, ma,
Sir.
take care, take care. That's all I can say. Don't miss the classes. Okay. Exams are going to be there. Okay. Already semester is coming to an end. Huh?
Yes, sir. Yes, sir. I understand, sir.
Right? Okay.